Good morning, students. In this class, we are going to discuss the formation of partial differential equation. What is meant by the formation of partial differential equation? Students, insert a ruler here. Okay, it's looking good. Fine. Formation means for any given equation, the function of x comma y comma z, a comma b equal to 0. So where x and y are the independent variables and z is the dependent variable, a and b are the arbitrary constants. Any differential equation is given, for example d square y by dx square equal to 0. What is the solution for this? The solution is, in case if you are integrating one times, you will get that dy by dx equal to some constant c. And then once again you are integrating this, you will get that y equal to c1x plus c2. So when you are integrating, what is the formation of the solution? The formation of the solution is containing the arbitrary constants c1 and c2. These are the arbitrary constants. Similarly, if you are differentiating two times, then the arbitrary constant will be eliminated and then you have to form the differential equation. In the same manner, the formation of partial differential equation, there are two types are there. One is eliminating the arbitrary constants. Second one is elimination of arbitrary functions. First we will discuss the formation of partial differential equation. Formation of partial differential equation by eliminating the arbitrary constants. So if you consider one equation, f of x comma y comma z a comma b equal to 0, which is equation number 1. So what is our aim? Our aim is to eliminate that arbitrary constants a and b, and we have to form the partial differential equation. So here we can write that a and b are arbitrary constants. So here z is the dependent variable on x and y. Dependent variable on x and y. So if you are differentiating one, differentiating equation number 1, with respect to x and y partially. So if you are differentiating one partially with respect to x and y, we get the two equations. So what are the two equations here? What is the equation number 1? F of x comma y comma z, a comma b equal to 0. So if you are differentiating z with respect to x and y, first you have to differentiate that function with respect to x, and then inside the function z is there. Z is a dependent variable on x. So therefore you have to write the dou f by dou z and then dou z by dou x. You know the notation, dou f by dou x equal to small p dou f by dou y is small q. So if you are substituting the dou z by dou x is p, this dou z by dou x is p, then we will get that dou f by dou x plus dou f by dou z into p equal to 0. It is equation number 2. Similarly, if you are differentiating one with respect to y, differentiating one with respect to y partially, we get, first you have to differentiate f with respect to y, and then as it is like that previous step, we can write that dou z by dou y equal to 0. So as we have seen that dou f by dou y equal to q, now dou f by x. So this small change here, dou z by dou x. Dou z by dou x equal to p, dou z by dou y equal to q. So we have to substitute here dou f by dou y plus dou f by dou z into q equal to 0, which is equation number 3. So we have to eliminate that. Two constants, we have to eliminate the two constants a and b from these three equations. So what are the three equations here? The given equation 1, and then we have to find that the equation number 2 and 3. We have to eliminate that the arbitrary constants a and b from these three equations. We can obtain the solution. We can obtain the solution. That is, so you can, how can you eliminate that a and b from here? That is, you can multiple or substitute or subtraction. So whatever it may be, that is, finally we have to eliminate that a and b, and then once you eliminate that a and b from these equations, then we can eliminate that, we can form the PDE here. So what is the solution here? You can apply the solution in the form phi of xyz p comma u equal to 0. So here you can see that the equation contains two independent variables, one dependent variable, and then p and q are the first order partial derivatives. So a few important note is there, when you will get that first order partial derivative, when you will get that second order partial derivative. That means we can write as a very important note. In case the number of arbitrary constants equal to the number of independent variables, number of arbitrary constant equal to the number of independent variables, then we will get the resulting equation, that is formation of equation of the PDE, first order partial derivative. First order partial differential equation. Okay. Second note is, in case the number of arbitrary constants is more than the number of independent variables, then the resulting equation for in second and higher order. That means in case the equation contains from the first node can show that for example, in case the equation contains x and y are the independent variables and the arbitrary constants a and b. Here we can see that equal number of independent variable and equal number of arbitrary constants. Then we will get that equation in first order. In case the equation contains x and y are the independent variables, a, b, c, therefore that is there are three arbitrary constants are there. Here we can see that the number of independent variables is less than the number of arbitrary constant. At the time you will get that the PDE in second order. Problems based on formation of PDE by elimination of arbitrary constants. Look the problems. Just have to write the question. Form the PDE by eliminating the arbitrary constants. A and B. From the equation z equal to ax plus by. This is a very simple problem. For any problem to form the PDE by eliminating the arbitrary constant, first you have to differentiate with respect to x and y. So what is a given equation here? Given equation is z equal to ax plus by. So here we can see that how many arbitrary constants are there, how many independent variables are there. How many arbitrary constants are there? A and B are the arbitrary constants, and then x and y are the independent variables. That means two arbitrary constants are there, two independent variables are there. So that means we will get the resulting equation in first order. So we can take this as equation number 1. Differentiating one partially. Differentiating one partially with respect to x, we get that dou z by dou x equal to a. That means dou z by dou x is, we know the notation p equal to a. This is equation number 2. P equal to a is the equation number 2. We are differentiating one partially. Differentiating one, equation number 1 partially with respect to y. We get dou z by dou y equal to b. That is u equal to p, which is equation number 3. So substituting 2 under 3, we are substituting 2 under 3. That means equation number 2 and equation number 3. What equation number 2 says? P equal to A. Equation number 3 is Q equal to B. In case you are substituting 2 under 3 in the equation number 1, we get the required PDE. We get the required PDE. What is required PDE here? Given equation is z equal to ax plus by. So from this, you have to substitute p equal to a, q equal to b. That means in the place of a, you have to substitute p. In the place of b, you have to substitute q. So we will get the required PDE z equal to px plus q. This is the First problem. Now we go to the second problem. Problem number 2. Eliminate the arbitrary constants eliminate the arbitrary constants A and B from z equal to ax plus by plus a square plus b square. It is same like the previous problem. Write the solution. What is given here? Given is z equal to ax plus by plus a square plus b square. The solution is differentiating one. We take this as equation number 1. Here also we can observe that how many arbitrary constants are there. What are the arbitrary constants? A and B are the arbitrary constants. And then what are the independent variables are there? X and Y are the independent variables. So number of arbitrary constants equal to the number of independent variables. So we will get that resulting equation in first order. So next we are going for any problem, as I told that you have to differentiate with respect to x and y. First we have to differentiating one partially with respect to x. We get dou z by dou x equal to a. So that implies b equal to a. This is equation number 2. Similarly, if you are differentiating one partially, with respect to y, we get that dou z by dou y equal to b dot q. It is b. That implies u equal to b, which is equation number 3. Substituting 2 and 3 in 1. Substituting 2 and 3 in 1. So what is 2 here? P equal to A, Q 3 is Q equal to P. That means you have to substitute A equal to P and B equal to Q in that equation number 1. You will get that Z equal to Px plus Qy plus Q square plus Q square, which is directed to P. This is the way to eliminate that arbitrary constant from the given equation. And if you are eliminating the arbitrary constant, then the partial differential equation will form. Then we will discuss one more problem here. Problem number 3. Form the PDE. by eliminating the arbitrary constants. By eliminating the arbitrary constants A and B from z equal to x plus a whole square plus y minus b whole square. For this problem, we can write the solution from the given equation. How many arbitrary constants are there? Two arbitrary constants a and b. How many independent variables are there? X and y are the independent variables. So what is the number of arbitrary constants? 2, and the number of independent variables also 2. Therefore, equal number of arbitrary constants, equal number of independent variable. So we will get the resulting equation in first order PDE. That means the PDE should contains that only P and Q. Okay, so that is the meaning of this. So how can we write the solution for this? What is given equation here? Given equation is that equal to x plus a whole square plus y minus b whole square. Therefore, if you are differentiating one, take this as equation number 1. Differentiating 1 partially with respect to x and y, we get that dou z by dou x equal to 2 into x plus a. That means x plus a equal to dou z by dou x is p, then cross multiply the 2 here, x plus a is p by 2, which is equation number 2. Similarly, if you are differentiate 1 partially with respect to y, that is beginningly we have differentiate only with respect to x. If you are differentiate with respect to y, we will get that q equal to, that means dou z by dou y equal to 2 into y plus y minus b, not y plus, y minus 2 into y minus b. So that gives that y minus b equal to q by 2. Is it that? So this is equation number 3. After differentiating with respect to x and y, we will get that equation number 2 and 3. Substituting 2 and 3 in 1. We are substituting 2 and 3 in 1. Two and 3 in 1, which gives that z equal to p by 2 whole square plus q by 2 whole square. What is the required PDE? 4z. That means z equal to p square by 4 plus q square by 4. Taking the LCM 4 and 4 here, cross multiple that 4 there. 4z equal to p square plus q square, which is the required PDE. Next problem. Form the PDE by eliminating the arbitrary constants. Fourth problem. Form the PDE by eliminating the arbitrary constants. By eliminating arbitrary constants A and B from z equal to A x power n plus B y power n. We can write the solution for this. Given z equal to A x power n plus B y power n, which is equation number 1. Differentiate one partially with respect to x and y. Differentiate one partially with respect to x and y. We will get that tau z by tau x equal to, keep it A there. Then differentiation of x power n is n into x power n minus 1. So this gives that t equal to an x power n minus 1. If you are differentiating with respect to y, you will get that tau z by tau y equal to b into n into y power n minus 1. So which gives that q equal to bn into y power n minus 1. Therefore, we can calculate that xp by n. From the equations, we will get that xp by n equal to a into x power n and yq by n equal to v into y power n. I take this as equation number 2. This is equation number 3. Substituting 2 and 3 and 1. We get the recursive PDE. We get the recursive PDE. So what is the recursive PDE here? Z equal to xp by n plus yq by n. Take n as LCM and cross multiple that, which gives that xp plus yq equal to nz is the recursive solution. Last one is fourth problem. Next we will discuss one more problem. Form the PDE by eliminating the arbitrary constants A, B and C from x square by a square plus y square by b square plus z square by c square equal to 1. Can we write the solution for this? So what is given here? Given different equation is x square by a square plus y square by b square plus z square by c square equal to 1. So here the given arbitrary constants, already arbitrary constants are there, a, b, c, and the independent variables x, comma, y. You can see here 3 arbitrary constants are there. 3 arbitrary constants are there, but only 2 independent variables are there. So here the number of arbitrary constants is greater than the number of independent variables. Therefore, you will get the resulting equation in second order. Okay, you will get the second order PDE. So how can we get the second order PDE here? The given equation is equation number 1. If you are differentiate 1, partially with respect to x, we get that 2x by a square plus 2z dou z by dou x by c square equal to 0. That is equation number 2. In case if you are differentiating 1 partially with respect to y, you will get 2y by b square, 2y by b square plus 2z dou z by dou y by c square equal to 0. This is equation number 3. Our aim is to eliminate the arbitrary constants a, b, c from this equation. From the above two equations, even if you are substituting the 2 and the 3 in 1, we are not able to eliminate that arbitrary constant here. Then we can, there is no other choice, we can go for the higher order partial derivatives. So 2 and 3 is here. If you are differentiating 2, in case you are differentiate 2 partially with respect to x again, what you get? 2x is 2 by a square, 2x by a square is 2 by a square plus 2 by c square. Keep it that. First you have to keep it z, then you are differentiate dou z to dou x with respect to x again, get that dou square z by dou x square. That is in that format of d of uv format. What is d of uv? You put a formula, multiplication formula, d of uv equal to udv plus v dv. This is the formula. Using the formula, the equation, first you have to keep it z, then you have to differentiate. You will get that z into dou square z by dou x square plus, in case if you are different, keep it the dou z by dou x, differentiate z with respect to x, you will get the dou z by dou x, which is equation number 4. That is equal to 0. Even if you are 2 times differentiating 2 with respect to x, then we are not able to eliminate the arbitrary constant. So we can go for that some alternate differentiation. For example, already we are differentiating 2 with respect to x again. So instead of differentiating with respect to x, we can differentiate with respect to y. Then we will eliminate that arbitrary constant here. We will try to eliminate the arbitrary constant. For example, differentiate 2 partially with respect to y. What are partially with respect to y. So what is the equation number 2 here? 2 is 2x by a square. That means dou by dou y of 2x by a square plus 2z by c square dou z by dou x equal to 0. So you are differentiating 2 partially with respect to y, then we will get that dou by dou y of 2x by a square is 0 plus 2 by c square is constant. Then you are using that multiplication formula of the derivative, you will get that first you have to keep it z, then you are differentiate dou z by dou x with respect to y, you get that dou square z by dou x dou y plus keep it dou z by dou x, differentiation of z with respect to y is dou z by dou y equal to 0. So it is 0 already. If you are cross multiply, it is a constant totally. This is the constant. So if you are cross multiple, that 0 by constant is 0. Therefore we will get the required PDE. The required partial differential equation is z into dou square z by dou x dou y plus dou z by dou x into dou z by dou y equal to 0. This is the required PDE. So from the above examples, we have learned one thing. In case the number of arbitrary constants equal to the number of independent variables, then we will get the equation in first order PDE. In case the number of arbitrary constants is greater than the number of independent variables, then we will get that the resulting equation in second order PDE. These are the things we have observed from this. In the next class, we will discuss few more problems on eliminating the arbitrary constants and arbitrary functions. Thank you.